briefly about the characteristics of the 4 blocks. We can describe them in sort of broad terms. 1 and 2 are very reactive. 1 is the most reactive of the metals. These things are not found on their own in nature. They form compounds because they're so reactive they can't stand to be alone. This is going to be real important because this is going to be how you're going to do all your compound stuff. The number of electrons at the highest occupied level, which we also call what kind of electrons? Valence electrons, is the same as the group number. Same as the group number. So if you're in group number 1, just hold up your fingers, don't yell it out. How many valence electrons do you have? 1. If you're in group 2, how many valence electrons do you have? Okay, good. You've mastered what we need you to know about the S block. That's really what we need to know about the S block. Okay, moving on. P block. When we talk about main group elements, we're talking about the S and Ps. And the number of electrons in the highest occupied energy level is the group -10. Okay. If I'm a group 17 element, how many valence electrons do I have? Hold up fingers. Yeah. 7. Because it's group number -10 tells you how many valence electrons they have. So if you're a group 13 element, how many valence electrons do you have? 3. If you're a group 14 element, how many do you have? If you're a group 16 element. Okay. So P block, and you can jot this on here. Valence electrons is group number -10. That's going to become really important because in another 2 months, I'm going to expect that I can look at you and go, okay, you know, oxygen is going to form what kind of ion? And you'll just know it. You'll know it as much as you know your middle name. We could shake you awake at 2 in the morning and you'll be able to tell me what ion given element will form. Okay. Group 18, of course, is part of the P block, but they are stable. They've got a full outer SANP. The P block you can't say anything about as a group. Their properties vary tremendously. We've got everything from metalloids, we've got metals, we've got gases, we've got noble gases. So we can't say anything cohesively about the P block. We talk about the groups within the P block, and they have similarities. Okay. Every non-metal that exists, except for hydrogen, is P block. And the metalloids are there. The halogens, which is group 17, that's your chlorine, fluorine, bromine, etc. Those are the most reactive non-metals there are. They're the most reactive non-metals there are, and we're going to do a lab with those probably next Tuesday, looking at their reactivity with other substances. So those are really, really reactive. You can think a little bit about why and probably figure it out pretty easily. We'll talk extensively about it later. Okay, the D block these are what we think of when we talk about metals. When I tell you, I'm going to give you a chunk of metal. These are the ones you think of. These are your classic metals. Copper and iron and nickel and gold, silver, things like that. These are what we think of as metals. So they're solids at room temperature, they're malleable, they're ductile, they're good conductors, all that stuff. The D block is also where we start to have those 4s2, 3d3, 5s2, 3d6. So the sum of the S and D is equal to their group number. Okay? If we had a sample of titanium, atomic number 22, what group is it in? 4. We know it's got how many S electrons? 2. Because it's got 4s2, and then it's got how many in that 3d orbital? 2. We've added, so we went 4s1, 4s2, 3D1, 3D2. You can always count electrons now. 1s1, 1s2, 2s2, 2s3, 2p1, 2p3, 2p4. You get the picture. It's not all that exciting, but if you're really bored and you need something to help you go to sleep. So the group number is equal to the sum of the S and B. Okay, this is those classic metals, those transition metals, Dblock. Non-reactive, unlike the alkali earth metals. This is what, if you get an implant, they used to do a lot of titanium alloys and platinum alloys on like artificial hips and stuff. Actually, they may still use a titanium alloy. Non-reactive, gold, of course, was an early filling material. It's soft, it's easy to pound into the shape of the cavity, and it's non-reactive. So that's handy. Okay, this is the last slide we're going to do. The F block, the big, the bad, the radioactive. Everything in that top row, the lanthanides, every single one of them is highly reactive. They are all reactive. The actinides are not only reactive, they're also radioactive. So radioactive means that their nucleus is not stable. It means that little nucleus made of protons and neutrons is actually breaking apart. That's why we call it nuclear radiation, because it is radiating off pieces of its nucleus. That's where the term nuclear comes from. Okay, that's where we're going to stop.